So the first part was to create a new header and CPP file called shape. So this is all done in SFML, adding a new item called shape, as well as adding a new CPP file called shape. And this CPP file will include shape.h using quotes. And remember that quotes indicate searching for that header file in the existing directory, whereas if you're using angled brackets, it'll search for the entire, wherever the include paths are specified. So typically that's like your standard C++ include libraries like IOStream and string. But occasionally if you want to, you can set up your project to also include several different folders inside of your project. For instance, Overwatch has dozens, if not hundreds or more, different folders where header files go in, probably closer to the order of dozens. And we have to include those as part of our include path so that we can include header files using brackets, because most of our header files are not in the same directory as our CPP. Okay. All right, so going back to lab, writing a class called shape, which has one public function, which is virtual. And I'm going to go over what virtual is again. So classes all are declared the same way. They have the name of the class and then braces. And I'm going to create a public function, draw, and this is the actual function I want you to write, which is it takes one argument here, which is an SFRenderWindow. And this argument here is a pointer to an SFRenderWindow. And we're going to get into how you can actually use this, but we do have one of these actually in our SFML. As if you look at this variable, SFRenderWindow, and go into our engine CPP, we have one of these variables here, this variable right here. Although keep in mind that this is not a pointer, but that's not going to be a problem. We can pass it as a pointer. And by putting an empty set of curly braces like this makes it so that this function doesn't do anything. And I just declared a function and I implemented it, and it doesn't do anything. I could also do this, where I put a semicolon here, and then inside my shape CPP, I could write the same function, only this time with a set of empty braces. Notice that when you're writing an implementation inside the CPP, you have to put the class followed by several colons to indicate that you're writing the function for this class, and you're implementing it here. So the other thing I need to do is, it's giving me an error because it doesn't know what a render window is. So just like how engine CPP has included this header file, you also need to include that header file here, so that it will know what a render window is. Now, we'll get into why this virtual keyword is important. I'm going to show you what happens when you don't have that virtual keyword in there and why it's important. This thing basically indicates to C++ that whenever someone calls this function on a class, it shouldn't call this function, this one necessarily. It should call the one that that's actually for the object that you implemented it on. So if I have a pointer to a shape, it doesn't know whether it's going to call the shape version of draw or circle version of draw. This virtual keyword indicates that you should be performing what's called dynamic dispatch, so it figures out which function to call at the time that you call it, as opposed to at the time that you compile your program. All right, so we're going to write a circle class, and notice here at the bottom we're going to have a draw function that overrides it in the base class, and circle is going to be a derived class from shape, which means that circle in the hierarchy is going to be a child of shape. So in order to make a class derive off another class, you put colon after the class name and then the access modifier you want. Remember that this access modifier indicates how you want to treat all the public or protected or private members of the from the base class. So by putting public in front of it, it basically means that keep the same access modifiers that shape had. If I had made this thing private, it will then hide and modify all of these access modifiers that you specified in shape to be private, but only for circle. And most of the time, like 99%, you're going to make this thing public anyway. So circle asks you to make a constructor which takes a radius as well as an x and a y position. So it also has one private member variable called mCircle. So these two work in conjunction. A private member variable here, you can create what's called a circle shape. So here, it's an SF : circle shape, which is something that literally is what we use to draw circles in SFML. If you forgot about that, there are some, I put a link at the top for all the different shapes that you can support. But it has one private member variable, I'm going to call it shape. m_shape. And there's going to be a constructor. And remember, the constructors are, you know it's a constructor because it has the same name as a class and no return type. But a constructor can take multiple arguments. So if I want to pass in a radius as well as an x position and a y position, I can require those arguments to be passed in when you're making the constructor. So in this case here, I'm going to actually make these floats. They could be integers, but floats will be a little bit more precise. The green squiggly here means that it can't find the actual implementation for this function. It's looking for where this function is implemented. So we haven't put this into our CPP yet, so we're going to do that now. And what I typically like to do is I just copy the entire prototype here. This is the function prototype. And then I paste it into the CPP file. And then I fix up the class namespace here to have the circle : : and now I have my function implementation. What I do in this function, though, is going to be a little bit different than what I do in shape, because shape doesn't have a default constructor, right? So here we're taking 3 arguments: radius, x position, and y position. And so what we're going to do is we're going to take this radius and the x position and the y position that we're forcing someone to pass in. We're going to use it to initialize our shape variable. Remember, we have a member variable called SFCircleShape. If I go to actually this declaration, this thing lives inside the circle class. So we're going to set the radius here, and we're also going to set the position as a result of the 2 floats that are passed in for the position. These 2 calls to set radius and set position will now be called when the circle object is created, which forces this circle to be placed and also sized correctly. And here's the draw function. We want to create the draw function for circle. This draw function is going to look identical to the draw function that's in shape, like so. So I'm literally going to copy and paste that, and then I'm going to go into my CPP file. I'm going to do the same thing. The thing about CPP files is you cannot have the virtual keyword in the CPP file give you an error, so remember to leave that off. And then you just need to inject the class : before the function name. Okay. And then on the window that's passed in, this window represents the main window that you're drawing everything to. So we're going to draw our circle shape. We're going to call it shape. Okay. So next, I wanted you to create an array of 3 pointers to a shape and use a new operator to create 3 objects of the circle class with different shapes and positions, and then writing a loop to call the draw function on each of these 3 shapes. And inside Engine, we already have one thing, but it's just a circle shape. It's not a, this right here is actually a class. If you F12 on this guy, you can see here, this circle shape is just a class that derives from a base class called shape. This shape happens to be exactly the same name as our class called shape, but it's not a problem because if you look here, close this, if you look here, shape is inside this thing called the SF namespace. So this is one of the reasons why namespaces are so important, because even though I wrote a class called shape and the guy who wrote SFML also wrote a class called shape, that's okay. It means that we don't have a collision because he put his in what's called a namespace. So anytime you use SF, you know you have to put SF : in front of it, right? And that's because everything for SFML is in the SF namespace. So for instance, I could have an SF shape, or I could have our own shape. These 2 things, let me include our header. These 2 shape variables are different. This shape is different from this shape, even though they have the same name. And the reason why that you can have a distinction is because SF here is indicated. This is also why I don't encourage you guys to ever using namespace. If I ever did using namespace SF, now I literally have no way I can actually use my own shape class. I just can't. Because I'm telling my program for the rest of this file, I'm existing in the SF namespace and only in the SF namespace. So anytime it encounters the word shape, it'll always assume it'll be the SF namespace. So just a little sidebar on why the shapes exist. Okay, so I'm going to get rid of the existing shape, the existing circle shape that's there, and not call draw on it. Instead, I'm going to create an array of 3 shape pointers. So I'm going to call this, there's That's a shape pointer, and there's going to be 3 of them. This is an array of 3. And then I'm going to initialize 3 circle shapes with using the new operator 3 times. And I could do this each on a separate line right here. Uh, 100. Or I could write a loop to generate these things randomly, which is what I'm going to do. Because I know I have 3 circles, I don't have to actually initialize each one independently. And I'm going to change this once we get to the rectangle, and then I could just do a rand here. And now I have 3 shapes that I've called new on, but they're stored in the pointer for shape. So I have a shape pointer. Remember that our hierarchy right now looks like this, where we have shape here. This is going to be the base class. This is our shape, right? And we have circle right now, which happens to be represented by a rectangle. And our hierarchy looks like this. So I have a pointer, though. I have 3 of these guys, right? 3 shapes. I have 3 pointers to a shape. Those pointers to a shape, though, can also point to anything that is derived from shape. That's why I'm allowed to call new circle here. A circle object is being stored in something that represents a shape pointer, and that's allowed because that's what inheritance allows you to do. And why is this important? Well, I can store any kind of shape in that array now. I don't have to store circles. I can derive new classes off of shape and still store them in the same array. And the reason why that's important is now I can write a loop that just does one thing, which is goes over each of the shapes and asks it to draw itself. So the shapes that I'm asking to draw also take a pointer to a window. Remember, that's our function. This is our function that we created called draw. It takes a pointer to a window. Now, the reason why it takes a pointer to a window as opposed to just a non-pointer is that if you did this, when you passed in something that's a render window like this, what you're actually telling C++ to do is when someone passes in a window, you want them to make a copy of that window because it's going to make a copy because that's what it assumes you want to do because you haven't told it otherwise. If you pass in a pointer, you're passing in the memory address of where the window lives, so you want it to just use the existing window that's already created in your program. So how do we get a pointer to this function when all we have is a window? That's a non-pointer variable. How do we get the memory address of this variable, window, to pass in so it looks like a pointer? Well, remember the ampersand operator here? This ampersand always gets back the memory address of the variable that comes after it. So in this case here, I could pass in window like so. However, it's an error because it says that this thing is not a pointer, and this draw function requires a pointer, and a pointer is just a memory address. So let's just give it a memory address of where the window is. This happens to point to the address of where this window variable lives, and it lives locally on the stack here. So this will mean that now when I call draw, it'll pass in a pointer. So a couple of things. I'm going to run this program and I'm going to get some huge circles. Let me shrink down these. So I have 3 circles here and they're being drawn on screen. It's going to be the same every time because I didn't. So I'll get different circles now at least. Every time I run it, I'll get a random set of circles. Now, what happens now if I get rid of this virtual keyword in front of draw? Can anyone guess?
It'll draw the shape, probably drawing the shape one.
It'll draw the shape, call the shapes version of function, which happens to do nothing. Well, let me just prove this to you. We could just make a I'm going to have a rectangle here, and I'm just going to set the fill color So when we call the shape draw, what I'm going to do now is draw a red rectangle, which happens to be a square, in the upper left corner. But why is it calling the shapes version when we have clearly a circle in here? That's because when we get to this call site where we call draw, because we haven't told the compiler that this function requires dynamic dispatch, meaning that this function should figure out which version of the function to call, because we haven't put the virtual keyword in it, the only thing it knows what to do is to look at the type of the object that you're calling it on, which happens to be the shape array, and the type of variables that are stored in this array are shapes. So when it goes to call draw, it doesn't do any kind of lookup to figure out whether it's a circle or a shape. It just assumes it's a shape because that's all it's being told to do. This function here literally is being told, hey, just call draw on the base shape class. So that's why if you put the virtual keyword in front of it, now whenever you call this function, it'll say, hold up, before I call the function that looks like it's going to get called, let me actually discover which version is going to get called. Okay.
Do all the draws need a virtual keyword?
No, only the base one needs a virtual keyword. You don't it propagates to the children, so you don't actually need to add virtual here. It just is a matter of practice to kind of add it everywhere because I copied and pasted it. It doesn't hurt to add it. It has no performance implication or whatsoever, but it does make it so that it just is more consistent, but this will still work. And anything derived off circle that implements draw will also be virtual as well by default. So it's optional. Okay, so now I get my circles that are drawing. Cool. And what this also means is that now if I make more classes derived off shape, it'll call the correct draw version. So let's continue and make a new class for square and a rectangle as well. And squares are just going to be slightly different than rectangles in that they will take one argument for their size instead of two. So I'm going to copy the entire class for circle. I'm going to call it square this time. And I'm just going to replace the pieces that I want to replace. And I keep the rest of these the same. And this is not going to be a circle shape. This is going to be a rectangle shape. Okay. And then I have my class for square. And I'm just going to do my rectangle here as well while I'm here. I'm going to create my rectangle class. Replace that. This takes a width and a height in the constructor now. And then let's go to our shape CPP. And we can actually just duplicate a lot of this. I'm going to duplicate this twice. So I've copied and pasted the constructor and draw twice. One for the square and one for the rectangle. And I just like to do this replacement up front because it's a lot faster just to do it this way. And it says size instead of radius. I'm going to call it size. I think I call this size here too for the square constructor. And the rest of the arguments are pretty much the same. So rectangle also doesn't take a radius, it takes a width and a height. And so when I call set size here, it's going to do the same thing. So there are our implementations. One of the things we do for coding standards is we tend to put these dividers in between every function implementation. So for now, at least, I'm just going to put them in between every class. So you guys can hopefully see where square and rectangle is in the code because I put these comments here. And I'll put one here as well. There is one other thing you can turn on, which is there's a built-in scroll bar option called use map mode for vertical scroll bar, which is kind of nice. So when you turn this on the right side of your scroll bar, this turns into a preview of the lines of code inside of your program. And the only reason why this is really nice is because when you search for stuff, like I just did a Control F for window, you get a little orange rectangles over where it found each of those results. So when I hit Control F and look for, I don't know, width, you can see on the right I have little rectangles. The orange rectangles indicate where width is found. So here are the two cases where width is. Okay. So now what I'm going to do is I'm going to create 3 different shapes. I'm not going to use a loop here. I'm going to use I'm going to create each one separately. I'm going to create a circle, a square, and a rectangle, and I'm still going to store them in the array. Only this time, for rectangles, they take a width and a height. And that's it. So I just created a circle, square, and rectangle. I'm still storing them into an array of shape pointers. The shape pointer doesn't care what type of objects is stored in it, as long as it's a derived type of object. What's nice too is that we don't have to make these all white. Because each shape has its own draw, what we can do is we can just update the fill color. So we can say make squares red, and we can make rectangles blue. So now we just changed the specific implementation of it. So now we have, what was that, France? I don't know. The colors of a flag, and you can distinguish them each apart from one another. Because each function is different, we also don't have to necessarily draw a rectangle just because he wanted us to. We could actually just draw a circle in here too. We have the ability to change the functionality of each class inside its own function without touching the other functions. We can actually randomize this too. We don't have to draw the same color every frame. We can just randomize for a rectangle. We just have it go crazy colors every frame if we want to, and only for the rectangle, right? Because the draw function for a rectangle is unique. It's not affected by the others. Right? Okay. Any questions? All right, we have a second lab that we need to do as well. Okay. So I went over this in class with the lab, so I want to talk more about how to do this with vectors. Now we have our nice shape classes and we have our psychedelic rectangle, which I'm going to temporarily comment out that portion. Let me put this up on Zool before I move any further so that you guys can grab it if you want to. I'm just going to put the CPP files on Zool. I'm not going to put the entire project. So you guys can add them if you want to. Okay, so I put a folder called Lab 1, which has the 3 files that I created. So let's move on to lab number 2. Lab number 2 was an extension on the first lab. It was to use the existing classes if you had. And I wanted to add circles dynamically and for as many as I want. So every time you click, I wanted to draw a circle. So let me just show you how to do this with a static array first. So let's just say that I have this array of all 3 of these. And I'm going to initialize these all to null. And what we're going to do is I'm going to let my player click 3 times to draw 3 circles on screen. But he's not going to be able to draw any more than that, and that's going to be a problem. But until then, we can make it work. So this is kind of a reminder of how to handle events. So if you remember, events are Windows telling you that something happened. While if you do polling, it's you asking Windows the state of the keyboard or the mouse. In this case, I want something to happen when I click. So I want a mouse button event. A mouse button pressed, that's going to be my event type. And if I know that I have this event type, I know that I've clicked somewhere, and I can do something based on that. So I can get the mouse position at this point, and I can create a circle. So I can say shapes at 0 equals a new circle. I'm going to make it a 50 radius circle, and I'm going to get the position at x. That's going to be my x position. And it's going to be my position at y of where I clicked. And I'm going to create a new circle right here. So every time I click, it creates a circle, but it's always putting it in the same element in the same spot in the array. So what I want to do is I want to create up to 3 and hopefully much more than 3. So how do I make it so that I'm not always putting it at 0? Well, I can create an integer that represents the insert index here, and I can do an insert index and then increment it. If you guys want, I can do this on a separate line just to make it more clear, but this is effectively the same as me doing that. And so this will let me do 3 circles. 1, 2, 3. What happens if I do a 4th circle? Nothing happens. And why is it that nothing happens here? Because I'm telling it to only draw 3 of them. So I could make this thing really big. I can make that number big enough to hold as many as I can. And actually we have a problem right now because every time I click, I'm doing really bad things with memory. Because what's happening is that I have an array that I'm telling it there's only 3 things in that array. But what I'm actually doing is I'm just assuming that there's much more space and I'm writing more elements in that array. Like I'm already at, what's my insert index here? I don't actually know what my insert index is. It's probably like 20 or something. And the problem is that in memory now, I'm just blowing away whatever happens to be next to that array. This is what's called a buffer overflow. This means that this shapes array represents a buffer. Have you guys ever heard of, like, a lot of hacks do this actually. This is a very common approach to hacking a game, or whenever you see someone get get root access on something. A lot of cases revolve around this very idea where you have some array that's allocated for 3 of these things and you are just writing past that array. And what you can do some really malicious things as a result. You can overwrite memory so that you can actually control the flow of execution for someone's program. There was some very heinous exploits you can do. You can cause any arbitrary code to run, which means you can do things like cheat, which is very kind of minor thing, or cause your game to crash, or whatever you want. And that's because we have this address of shapes. And can you guys see here, this little thing turned red up here? It's really hard to see. Let me run it again. So I'm here, watch. It's just overwriting what happens to be here. Now, I'm getting a little lucky. There's not a ton of interesting things here in memory. But if I do this enough, do you guys see there's actual real memory down here? And it's going to start overwriting that. And that's when it starts to get really bad. So this is a problem. Static arrays aren't really built for handling growth. They're not really meant for handling anything outside of the array bounds that you specified. I told it that there's only 3 shapes I want to deal with. This is where vectors come in. Vectors allow us to create any arbitrary number of objects, and that vector will allocate more memory as it needs to accommodate however many things you want to add into the array. So instead of having an array of 3 shapes, why don't I just effectively create an array of unlimited shapes? So if you include this vector header, this is a built-in standard library header, you can use a vector to represent a dynamic array, where a dynamic array really just means an array that can grow or shrink as needed, whereas a static array represents, hey, this array never changes size ever. So instead of creating a static array like this, what I can do is I can just remove this portion, get rid of the 3, and instead wrap this shape pointer in std vector. Wrapping it in an std vector and putting angle brackets around it indicates that now I want this variable shapes to be represented by a dynamic array of shape pointers. And now what I can do is, instead of calling this to add a circle, there's a function you can call on a vector called pushback. And pushback literally just means add another element to the end of the list. So I'm going to call pushback, and it's a function that takes an argument, and the argument it takes is a type of shape pointer. And the reason why it knows that is because this is a templated class. And as far as templated classes are concerned, really this thing represents, this vector can hold literally any variable, even ones that you have created. And C++ will generate code to support your variable. That's what these angle brackets actually mean. It means that here I'm storing something that is a shape pointer, but I could easily also store, I could have a vector of whatever type of objects I want. So here I'm going to make all these vectors. I'm going to make one that stores circle shapes. I'm going to make one that stores ints. I'm going to make one that stores bools without a pointer. And I'm going to make one that stores a float. I'm going to make one that stores a character. And then pointer of strings. All of these vector variables, all of these 6 variables I have, are all using the same exact class. vector hasn't changed. I haven't written any new code for vector. But the way vector works is that because it's templated, it takes the type that you pass in between angled brackets and says, okay, I will consider myself to be a list of these types that you say. And during the compilation process, when C++ encounters this line of code and it compiles that line of code, it will actually generate code that gets then compiled again to support this bool. That's what the power of templated types are. And templated types are everywhere in the standard library. But what the benefit it gives us is that we can store anything we want in there. We happen to be storing shape pointers, but we can also store bullets or asteroids or Overwatch heroes or whatever else you want to store. But I happen to be storing shapes. But the functions you call on this vector is exactly the same no matter what type you use. And push back is what you do. And notice I'm pushing back a new circle here because it stores a pointer to shape. And so I'm going to pass it a pointer to a shape here. And now what I can do is, see how I had this loop that loops over it 3 times? Well, I don't have to loop over it 3 times. I can ask the array, how many do you have? By calling size, and size is a function that takes no arguments that returns back how many things are currently in that vector. In this case, every time I click, it's going to add a new shape. So this size is going to go up by 1 every time I click. And then this shapes at I.null. I don't actually need this check here. I could just call draw. But now that I have a vector, there's actually no limit to how many of these shapes I can add. I used to be limited to 3. Now every time I click, it adds a new element to this vector. If I put a breakpoint here, I can see that shapes has a size of 36 right now. That's how many elements are in there. So when I call size, that's what it returns. I step, and now it has 37, as you would expect. So I have 37 circles right now. And I have 38 here too. I can also remove elements from the array if I wanted to. Like this array can grow and shrink too. The way that you're going to remove them, I'm going to show once we get to destroying objects for asteroids. But doing this now, there's really no limit to how many. I mean, there is a limit as far as memory considerations are concerned, but as far as our like feasible limit that we are using, we're probably never going to be able to hit that just by clicking. Like you could click 10 million times and still not hit that limit. So keep that in mind. It's effectively infinite for our game, right? Okay. Questions on vectors for lab number 1. Vectors are really useful. Every game or in every engine has the same concept of vector. We don't use like the standard library for Overwatch. We have what's called G arrays, which are growable arrays, and we tend to have like it's the same exact functionality though. Like you add and remove things and it grows dynamically. Okay. Now make it so when I right click, I add a larger circle or a square. So what I can do now is I can put a break, or I can put a if statement here. Button. If it's 0, that means it's left click. And I can add a bigger circle if it's right click. Let me make a 150 circle. So when I left click, it's going to add a small circle, and then right click is going to add a bigger circle. Cool. I can also just change this to be a square. I don't have to have it be a circle. Without changing any other code, because this is an array of shape pointers, I can add squares here. There's no real difference as far as the code is concerned with whether it's a square or a circle. With a rectangle, I do have to pass in a different argument for width and height. So this is draw me some vertical lines. But the code is very straightforward as far as what I want to do. I'm still pushing into this array of shapes. Now I want to make it so that as long as I'm pressing the mouse button and moving the mouse, I'm going to add circles to where the mouse cursor currently is. So in this case here, I don't really want to use events. I want to use polling. I want to ask, hey, where is the mouse button right now? Is the mouse button pressed right now? So I'm going to do that here. Is button pressed? Left. So if the left mouse button is pressed, what I'm going to do is the same code. I'm going to add some circles, like so. But I can't use the event mouse button X here because it's not in an event loop. It's not handling events right now. Instead, what it's going to do, I'm going to ask for the position. And I'm going to get the position of x and y. And if you remember back to our previous labs, this position here lets you take in a window that you want to pass in. One thing I want to note is we're not passing in a pointer to a window here, and why is that? Why does that still work? Well, if you actually look at this function for getPosition, notice here it's taking in an address to a window. This is a pass-by reference. This is another way, an alternate way to pass in arguments that without having to do a copy. You'll see both of these. And by doing this, you can just pass in the window without having to pass it in as a pointer instead. There are some differences. There are some like nuanced differences over using one or the other. Typically, like when you, it's pretty much, the main difference is really who do you want to do error checking in case this thing happens to be null. For instance, for our function, remember, if this pointer inside of our draw function, if window was null, what happens if I try, oops, what happens if I take a null and I call draw on null? This crashes the program, right? So if I actually pass in null for a window, like so, this will cause my program to crash. That's why we pass in the address of window instead. And the main difference is that if you don't take a pointer, there's no way you can crash because these functions here don't take pointers, so there's no way to actually cause it to crash in that case. All right, so now I have my left mouse button pressed, and I'm getting the position, and I'm pushing back some shapes as long as I'm pressing the left mouse button, wherever the mouse button is, and now I can draw my circles. This is literally just happening because it's asking every frame where the mouse button is and allowing me to click. Okay. And then make it so the mouse wheel up and down can change the size of what you're drawing. This is also pretty straightforward. What we do is we're going to have a circle radius, which is going to be 50 as a variable. And we're going to replace that and that. And this circle radius is going to grow and shrink every time we get a mouse button. And instead of this, we can use the mouse wheel scrolled. So I'm drawing these, and I can mouse wheel up to grow or mouse wheel down to shrink. Okay. And then the last one was, how would you change the colors at a circle time every time you add one? Can you make the colors random? And how would you make the colors gradually change as you draw? If you want to make the colors random, you could do that too. So we have a way to change the color of the circle via constructor. Although for me, I don't really want that to be an argument to the constructor. I want the default color to be white. So here's an option that you can do if you want to change the color. You can add a new function that is called setColor. Oh, and what we're going to do is we're going to take a color. One thing I want you guys to realize too is when you have something that is a color or anything that has multiple components to it, so color has a RGB, so you can think of it as a structure that has multiple variables in it. It's expensive to copy that when you're passing that through a function, so this is a good case where you can use a pointer to a color, or you can use an ampersand to also do that too. So just to give you some difference here, we can pass in an ampersand. This is a pass-by reference, right? I'm putting a const in front of here to indicate that, hey, this color that you're passing in, I'm not going to change it at all. This allows the compiler also to optimize it so that it knows that, hey, this thing is only read-only, no one's going to be able to change it. This is a very common pattern. I don't really need you guys to worry about that too much yet. Even if you don't do this, it's fine. Here's my set color. I'm going to take my shape and I'm going to set the color here. I've added a member function now that lets me set the color of a circle. So if I go here, when I make my circle, I can take my pointer to a circle, and I can create a random color here. Like so. And let's just add a little bit of variance in the green and blue. Okay, it's going to be mostly kind of pinkish, like a pastel-y color. So every time I'm adding a circle now, it's randomizing it. Make small little randomized colors, big ones. How would I make it so that as I'm drawing them that they change color? Well, instead of making this random every time, I could make a variable here. Start off with white. And then every time I draw a circle, I can take the R value and add a little bit to it. As long as if circle color dot R is less than 255, then add the R. Else if circle color dot G is less than 255. And then we're going to pass that in here. I'm actually going to set this thing off as, so do 10, 10, 10. So it starts off and goes gradually more towards white. So by incrementing it every time I add a circle, I can also adjust the color that way. Okay. All right. Questions? That was the, what's that?
From white to a different color.
Like what color you want?
Blue.
Okay. In this case, you would start off at 255. And blue is the absence of red and green. And then you don't touch blue. So you start off at pure white, and you reduce the amount of red and green in here to make it blue. You can also pick a target color. I mean, you actually can make it so that you have two colors. One that might be a target color. Let's see if I can do this. So 0, 0. Let me think if there's an easy way to do this.
I need another method to do it.
Well, the reason why this is kind of nice is if we can actually set up a target circle color, we could change this variable and then get new different colors every time.
Yeah.
Yeah, this isn't going to work here. You can make a target circle color this way. You have your deltas here. This is how much you have left to go. This is totally not really great, but we're going to this is what's called hacking. This is doing the most brute force method that you can think of without thinking too much more about it. There's probably another way to do this, but
That's pretty much kind of like it.
we can improve it after we do our initial one. What I'm doing here is I'm calculating how much I still have left to go. Oops, I went to green because I screwed up. Thought the color RGB. I probably screwed this up somewhere. Oh, yeah, because I'm shooting for green here. like so, and we can change this thing to be like so. Pink. And then you could change this variable.
Like once the colors are the same, just randomize it.
Just make it when you right click, it changes. Some pink, and gray, blue. Every time I right click, it's picking a new color for me to shoot towards. Just doing transitions between them. Not that there's much of a game in there, but maybe there's a paint program hidden in there. I'm not sure. All right, so let me copy this to Zool as well. All right, now onto the homework, the last homework. Okay. Write a class called player. The player will have the following private member variables, and I wanted to just draw like that, but it's going to use the sprite that exists inside this space shooter zip. So I'm going to use player ship to blue, and I'm going to go and I'm going to update our existing program to just have a ship in it. So let me put our ship texture in there. So I want to make a new class called player, but I'm going to put that into a player header. And this player is going to have a few member variables inside of it, notably these three. And we're also going to have to include our header for graphics again. And these are going to be private, even though they're private by default. I like to be explicit about that. Then it will have the following constructor. So this constructor here takes a texture path and a position, and we're going to initialize these textures and the position accordingly. And so I'm going to create a declaration here inside player.cpp. And we're going to do kind of similar to what the circle did. We're going to set the position. So we have this position variable. We're going to set that. We're going to load the texture because we have this texture variable. We're going to call load from file here. We're going to pass in our texture path that we specified. And we're going to take our sprite and we're going to set the texture based on the texture that was loaded here. And similar to the shape, we're going to have a draw function that looks almost identical to the shape draw. And we are going to make this thing virtual. And I'm going to take this whole thing and I'll put this into shape, into player. And putting player : : in front of it. And this window is just going to draw the sprite because that's what holds our texture. Cool. So in our engine now, what I'm going to do is I'm going to comment out the line that I'm just not going to click. I think that's what I'll do. I'm going to make a new variable that's called a player. That's a pointer to a player. And I'm going to create an object for it, instantiate the object. And this player, I need to include the header for it. And it takes a few arguments. The first argument is going to be the path to the texture. And the path to the texture is this name. And then the position is going to be a x and a y, or SFVector2. And I want it to be at 400, 400. And then we just have to call draw on this guy. So at the bottom here, after I draw my shapes, I'm going to draw and pass in the window. So this guy, it can't access draw or constructor or the constructor because I didn't put the public keyword in front of it, so it couldn't build it. And there's our player ship. He's not in the actual right position though. How do we get this guy here to make him draw on the screen at the right position so he's not in the top left corner? We're setting his position here. But what is his position actually used for? Well, the sprite is actually the thing that dictates where his position is. So we're going to set the position here. And this is going to be important because we're going to use this position as the thing that we actually move in the world as we're moving the player with the keyboard and mouse. So there's our player. It's always on top because we draw him last. Right? And that's it. This player header is very simple, but we're going to leverage this and we're going to turn this into something that's more broad, that we can use this for other things. Like we don't have to pass in a ship there. You know, the way we have this set up now, we can actually pass in anything. Why don't we have a vector of players and I can take all sorts of images and I can draw them. So if I have this vector of players and I have 5 ships in here, and this one's at 200. And then at the bottom here, I can write a similar loop to our shapes. Instead of calling shapes.size, I'll call my player, because now I turned it into a vector. And I can have as many players as I want on screen as well. Right? There's no reason why I can't use a vector for that too. There's also no reason why I can't put different ships in here. They all function the same. They all have positions and sprites. But our class takes care of loading textures and assigning different sized, different positions for us. We have different objects to represent each ship. And if I just want to remove some of these ships, I just delete them from initializing. I don't have to touch any of the rest of the code because our vector is sized appropriately. So I have 1 ship here. Or if I wanted to, I'll make 10,000 of these. I'll just make 10,000 ships, and it'll take a little bit of time to start up, but it'll make 10,000 of those objects, and now I have 10,000 ships on screen, right? I don't know if I can draw. I can still draw circles here, right? That's the power of the vector. Right? I can also change this. This can actually be a random number too. I don't have to necessarily have the same amount. Maybe one run I'll have 20 ships and another one I'll have 700 ships, right? And every time I run this I'll get a different number of ships. And the array will grow and accommodate however many I need. Okay. That's what this vector does. Okay.